Michael T. Osterholm, Deadliest Enemy, Our War Against Killer Germs. Embark on a gripping journey through the world of deadly epidemics, as Michael T. Osterholm's Deadliest Enemy, Our War Against Killer Germs provides a first-hand account of the challenges and complexities faced while solving public health crises. With historical contexts and contemporary concerns, the book delves into the intricacies of disease surveillance, case definitions, and containment. Prepare to witness the stark reality of our vulnerability to global pandemics, and discover ways we can work collectively to prevent the impending catastrophic consequences. This book's summary illuminates the intricacies of epidemiology and explores our urgent need to develop a unified, international response to the threat of infectious diseases.
Unraveling the HIV Mystery. In 1981, mysterious rare diseases appearing in young adults puzzled the CDC. Dr. Michael Osterholm, an epidemiologist, was among those who investigated the enigma that would later be known as HIV. Through the methods of case surveillance and case definition, the team eventually identified the disease as a retrovirus of sub-Saharan African origin that attacks the immune system and spreads through blood transfusions and sexual activity. This outbreak was a black swan event, leading to an unprecedented hyperendemic affecting millions worldwide. In 1981, the Centers for Disease Control and Prevention, CDC, in Atlanta faced a baffling mystery. Young, healthy individuals in New York and California suddenly developed rare diseases like pneumocystis carinii and Kaposi's sarcoma. This was the beginning of an unknown epidemic we now recognize as HIV. Understanding an epidemic required detective-like skills, piecing together the puzzle of the disease. Epidemiologists like Dr. Michael Osterholm aimed to track and trace the spread of diseases to control and prevent their impact. They had to scrutinize every detail: who contracted the illness, where it appeared, and any notable patterns. To crack the HIV puzzle, Osterholm and the CDC began with case surveillance. They surveyed doctors in New York and Los Angeles to identify cases of people presenting with these rare diseases. It soon became apparent that young, gay men were most often afflicted with conditions typically associated only with the elderly. With the collection of more data, Osterholm's team could provide a case definition, a precise description of the culprit. The facts unfolded rapidly. The disease was a retrovirus, attacking the immune system and spreading through blood transfusions and sexual activity. This retrovirus likely emerged in sub-Saharan Africa and, crucially, it was entirely new to science. To epidemiologists, the HIV outbreak exemplified a black swan event, a rare and unpredictable occurrence with massive consequences. HIV's impact was staggering. Within just a few decades, the virus went from a mere several hundred cases to infecting an estimated 40 million people. It transitioned from a pandemic to a hyperendemic, a persistent and widespread public health problem. Although the CDC's epidemiologists could not halt the spread of HIV, their work laid the foundation for future research into its prevention and treatment. Their unwavering dedication and innovative methods eventually unlocked the answers to one of the 20th century's most alarming and mysterious health crises. Unraveling the TSS Mystery. In the early 1980s, a sudden surge of toxic shock syndrome, TSS, cases alarmed parents and medical professionals alike. Epidemiologists, like Michael Osterholm, sought patterns to identify the cause, which seemed connected to menstruation. However, when superabsorbent tampons by Procter & Gamble were initially blamed, further investigations revealed the root cause to be specific bacteria attracted to high absorbency materials found in various brands. Through trial and error, scientists then pinpointed the correct culprits, leading to new regulations that curbed the rise of TSS cases. In the early 1980s, a horrifying phenomenon plagued families across the United States as teenage girls increasingly suffered from toxic shock syndrome, TSS, a life-threatening condition. Seeking answers, epidemiologists like Osterholm scoured for patterns to determine its cause. The first clue emerged when the majority of TSS patients were found to be teenage girls experiencing symptoms just a few days into their menstrual cycle. This indicated a clear correlation between TSS and menstruation, but researchers needed more evidence to uncover the root cause. To collect comprehensive data, Osterholm and colleagues conducted a case control study that compared detailed information from both TSS sufferers and similar individuals who were unaffected. The results revealed a startling connection. Most TSS patients used a new type of superabsorbent tampon by Procter & Gamble. While this discovery led many to conclude that the specific brand was responsible for the illness, they were mistaken. TSS cases persisted even after Procter & Gamble withdrew its products from the market. Further research demonstrated that the true culprit was not the tampons themselves, but specific bacteria that thrived in high-absorbency materials common to several tampon brands. Procter & Gamble's tampons had merely been the most popular choice. Once the root cause had been identified, new regulations and practices were implemented to restrict the use of harmful materials, ultimately bringing the wave of TSS cases under control. Through this experience, Osterholm learned an invaluable lesson. Solving an epidemic could require a trial-and-error approach, but with persistence and critical thinking, the errors could be minimized and lives saved. Pandemics, our greatest threat. While cataclysmic events like nuclear war and meteor strikes may capture our imagination, the most probable danger to human civilization lies in infectious disease pandemics. The Earth experiences these more frequently than other disasters, and unlike geographically isolated catastrophes, pandemics can span the globe and inflict devastation over extended periods. Our interconnected world relies on trade and shared resources, making the potential collapse due to a deadly pandemic all the more profound. The greatest pandemic threats stem from viral respiratory infections and antibiotic-resistant bacteria, which, if unleashed, can rapidly proliferate and defy current medical treatments. Thus, our peaceful coexistence with such pathogens may be more fragile than we realize. Pandemics lurking in modernization. The surge in both human and animal populations, along with rapid globalization in the modern world, has amplified the risk of pandemics. Effective defenses against such outbreaks include proactive vigilance and widespread vaccination efforts. 1918 was a devastating year when a catastrophic flu swept across the world, claiming an estimated 100 million lives. As chilling as those statistics are, the modern world faces an even greater vulnerability to a new pandemic. This vulnerability arises from certain conditions that favor the emergence and spread of infectious diseases. Infectious pathogens tend to thrive amid large, interconnected groups of people and animals, allowing diseases to jump from one host to another. Fast forward from 10,000 years ago when small communities limited the reach of diseases, and you have today's world where both human and animal populations have skyrocketed. Since 1900, human numbers have risen from below 2 billion to almost 8 billion, and the chicken population has surged from 3 billion to 20 billion. Consequently, the likelihood of new deadly strains emerging has increased dramatically. Moreover, the rapid interconnectivity brought by globalization is another decisive factor. Long gone are the days when months or even years were necessary to travel far away. Thanks to air travel and global commerce, humans, animals, and the diseases they carry can cross the globe within hours. With over 8 million people flying daily, the potential for transmitting illnesses is alarmingly high. This interconnectedness enables a person infected by a novel disease at a factory farm, for instance, to spread it beyond borders, resulting in catastrophic consequences for communities worldwide. Two main defenses against the spread of pandemics are constant vigilance and vaccines. When employed strategically and systematically, vaccines can immunize entire populations against even ubiquitous illnesses. Several diseases, such as whooping cough, smallpox, and measles, have been greatly subdued within the 20th century alone. Supporting and funding vaccine research and distribution are indispensable in preventing outbreaks from escalating into global pandemics. If harnessed wisely, advanced scientific efforts could even eradicate some of humanity's most pervasive enemies, tuberculosis, malaria, and HIV. Nonetheless, scientific advancements could also pose dangers, as demonstrated in subsequent discussions. The looming bioterror threat. Imagine facing a flu that kills nearly 70% of those infected. Such a deadly strain, H5N1 influenza, exists among birds, and in 2011, a research team created a version of the virus that could infect ferrets. Scientists work to prevent human-to-human transmission, but their research has sparked concerns about potential misuse. The rapid advancements in life sciences, particularly the CRISPR technology for DNA editing, have produced a double-edged sword. These technologies can create life-saving medical breakthroughs but can also be weaponized to spawn deadly pathogens. The dilemma can be seen in the term dual-use research of concern used to describe CRISPR research. In 2016, the U.S. Senate Armed Services Committee labeled gene editing a global danger. Biological warfare, including the intentional release of deadly pathogens, presents a unique challenge, difficult to prevent, contain, and recover from. Researchers have considered various scenarios for biological warfare. The potential genetic modification of smallpox garners one of the biggest concerns. A bad actor could engineer a more contagious and treatment-resistant strain, infecting multitudes of people before symptoms even manifest. In this case, the realization and response to the emergence of the disease could come too late. Anthrax also poses a serious threat. The toxic microbe can easily be cultured in a lab and disseminated in powder form. Studies estimate that a small plane spraying just 200 pounds of anthrax spores could result in 3 million fatalities. Although governments have made some efforts to counter these potential catastrophes and created plans for medical responses in the U.S., such as vaccine stockpiles, there remains no comprehensive national strategic plan for biodefense, according to a 2015 Department of Homeland Security report. The ongoing tension between science's potential for good and its devastating misuse underscores the urgent need for global collaboration and thoughtful preparedness. On the brink of pandemics. The dangers of pandemics, like the 2014 Ebola outbreak, are ever present with the potential to impact the global community. It's a delicate balance of vigilance, luck, and preparedness that keeps these disastrous outbreaks at bay, and governments should heavily invest in research for effective prevention and containment measures. Once upon a time, a young boy played near a hollow tree in southeastern Guinea, unaware of the bats nesting above him. Little did he know, these creatures were carrying a deadly virus, Ebola. In a matter of months, this rare and fatal virus claimed the lives of over 10,000 people from hemorrhagic fever. This tragic tale marks the beginning of the 2014 Ebola outbreak, the most extensive instance since it was discovered in 1976. The frightening reality is that a new global pandemic could emerge at any moment, from anywhere. Ebola, a harrowing disease believed to originate from fruit bats, can cause fever and eventually lead to internal bleeding and organ failure. While previous outbreaks remained small and isolated in Congo, changing population patterns opened the door for the virus to find a larger pool of victims. Fortunately, two key factors kept the 2014 Ebola epidemic from becoming a global pandemic. First, the virus is not highly contagious, spreading only through direct contact and after symptoms become visible. This attribute, combined with the persistent containment efforts of thousands of doctors, contributed to curtailing its spread before it spiraled out of control. However, the situation could have been dramatically different had the virus mutated into an airborne form or infiltrated Africa's migratory agricultural worker population. In such scenarios, the disease could have reached every corner of the globe. Often, it's a combination of luck, diligent work, and preparedness that keeps pandemics in check. Take, for example, the case of MERS, Middle Eastern Respiratory Syndrome, a coronavirus that first emerged in Saudi Arabia in 2012. With a staggering mortality rate of 40%, the virus emergence was a sobering reminder of the threats to global health. To combat MERS, epidemiologists painstakingly tracked its spread while doctors enforced strict containment measures. Although practitioners successfully controlled the initial outbreak, it resurfaced in South Korea in 2015, necessitating further heroic actions by healthcare professionals to prevent widespread infections. Today, both Ebola and MERS remain contained, but their existence in fruit bats and camels poses a lingering threat. These viruses could re-emerge at any time, emphasizing the need for governments to heavily invest in research, vaccines, and preventive measures. As history demonstrates, the search for a cure could be lengthy, but undeniably crucial for global safety. The growing mosquito menace. Mosquito-borne diseases are a pressing and escalating global public health concern. With over 3,000 mosquito species worldwide, a few act as carriers for life-threatening illnesses like dengue fever, yellow fever, and the West Nile virus. As the climate warms and tropical regions experience human population growth, billions of people now live in high-risk areas. Outbreaks of potentially fatal mosquito-borne viruses are on the rise and spreading to new regions. Scientists are exploring ways to control mosquito populations and prevent the transmission of these diseases, but challenges remain in combating this growing threat. Mosquitoes may seem merely annoying for those living in milder climates, but for billions of people residing in warmer regions, these bloodsuckers pose a serious danger. A single mosquito bite can lead to severe illness or even death. Over 3,000 mosquito species exist worldwide, with most of them simply causing harmless bites. Nonetheless, some species, including Aedes aegypti, are far more dangerous. These mosquitoes can transmit deadly diseases such as dengue fever, yellow fever, the West Nile virus, and chikungunya. These insects act as vectors, carrying pathogens from one organism to another through their infectious bites. Scientists have known about mosquitoes' role in disease transmission for more than a century. Governments and health organizations have attempted to eradicate these dangerous mosquito species through pesticides and vaccination programs. However, human population growth in tropical areas and the accumulation of waste, like plastic containers, have provided a fertile breeding ground for species like Aedes aegypti. Now, approximately 4 billion people live in vulnerable regions, leading to heightened rates of mosquito-borne virus outbreaks and the expansion of these viruses into previously unaffected areas. The chikungunya virus, formerly limited to Africa, has now infected thousands in India, Myanmar, and Thailand. Furthermore, as more individuals become infected, viruses can mutate and become deadlier. Zika, once a rare and mild illness, transformed into a major threat in 2015 as it swept through South America, affecting over 1 million people. Scientists are working diligently to restrain the spread of mosquito-borne diseases. Possible solutions include modifying mosquito populations to prevent them from serving as vectors. However, even with modern advancements, combating these diseases remains an ongoing challenge. Facing this growing mosquito menace requires continued research and innovative thinking to protect global public health. The looming antibiotic crisis. Imagine falling ill and finding that the usual antibiotics are no longer effective in treating your condition. This could be a grim reality as antibiotic-resistant microbes rapidly evolve. Since the 1930s, antibiotics have been successfully combating diseases like tuberculosis and staphylococcus. Sadly, the overprescription of antibiotics has led to the emergence of resilient bacteria. Already, up to 40% of pneumonia-causing Streptococcus pneumoniae strains exhibit resistance, and methicillin-resistant MRSA claims more lives than AIDS annually. To slow this predicament, physicians must curb unnecessary prescriptions, governments should regulate livestock antibiotics, and pharmaceutical companies need to focus on exploring new antibiotic solutions. Taking these precautions is crucial to avoid reverting to an era when simple colds were lethal and surgeries perilous due to infectious threats. Influenza's looming global threat. A dangerous new strain of influenza could cause a global pandemic at any moment, threatening numerous lives and overwhelming health systems around the world. The annual flu is already deadly due to genetic mutations, but the increasing proximity between humans and animals speeds up the virus's evolution. Preventing a pandemic can be achieved by understanding the next potential outbreaks and taking appropriate precautions. Imagine this: you turn on the TV and see a breaking news alert about a deadly new flu strain discovered in China. This strain kills 30 to 40% of infected patients, hospitals are overcrowded, and cases are popping up worldwide. The WHO has declared a global emergency. This may sound like a scene from a disaster film, but it could very well be our future. Influenza is the most significant risk for triggering a global pandemic. Seasonal flu caused by the influenza virus is familiar to many. In general, it produces mild symptoms, but it can kill about 40,000 people each year in the United States. In extreme cases, like the 1918 flu pandemic, the death toll can be considerably higher. This fluctuating fatality rate happens due to genetic mutations in the virus. Influenza often resides in birds, pigs, and other domestic animals. It can slowly evolve through a process known as genetic drift or change rapidly by swapping DNA with related viruses, called genetic reassortment. Each year, new flu strains emerge, identified by their surface proteins, hemagglutinin, HA, and neuraminidase, Na. With 18 known HA subtypes and 11 Na subtypes, there are nearly 200 potential virus combinations. For instance, the deadly flu of 1918 was an H1N1 virus, while the 1968 pandemic was an H3N2 strain. As humans and animals worldwide increasingly live in close quarters, the flu virus is mutating more quickly than ever before. Scientists are deeply concerned about two strains found in China, H5N1 and H7N9, which have a much higher mortality rate than past flus. Although these strains currently don't spread human to human, the rapid evolution of the virus might make human transmission possible. A highly contagious mutated H5N1 strain would spell disaster for global health. Because the flu can transmit via the air, through coughs, breath, and sneezes, it spreads rapidly among human populations. Even a relatively low percentage of severe symptoms could still overwhelm healthcare systems worldwide. While the prospect of a global influenza pandemic is grim, hope remains. By learning about and preparing for potential outbreaks, we have the power to prevent the next big pandemic. United against pandemics. Despite the imminent threat of widespread diseases, humanity can overcome future pandemics through aggressive collective action, investment in vaccine research, international cooperation, and adopting a holistic approach to public health. The stakes are high, but these challenges are not insurmountable if we prioritize them together. Killer strains of influenza, antibiotic-resistant bacteria, and bioterrorism threats may make our future seem hopeless or grim. However, it's essential to remember that infectious diseases can be controlled and their impact minimized through collective action and preemptive measures. Humanity must be proactive in preparing for the next global pandemic by identifying potential threats and investing resources in preventing them from becoming widespread. Take the influenza virus as an example. We know that it is the most likely candidate for a future pandemic, and our current vaccine technology needs constant updating, often producing vaccines with limited effectiveness. By significantly increasing funding and support for flu vaccine research, we can revolutionize the process and create advanced vaccines, which would be more effective against a larger number of strains. However, this effort alone is not enough. Preventing pandemics requires strong international cooperation, much like our battle against climate change. Establishing organizations like the Intergovernmental Panel on Pandemics would help coordinate global efforts and resources more efficiently. Additionally, we need specialized organizations to address the growing threat of antibiotic-resistant microbes, control disease vectors such as mosquitoes, and ensure that emerging biotechnology is used responsibly. A crucial part of this global effort is recognizing the interconnectedness of all life on Earth. Adopting a One Health perspective will help address the issue of infectious diseases by understanding the interactions between humans and animals. Both human and animal populations must be considered when planning public health initiatives. Fighting pandemics may seem like a Herculean task, but it's not impossible when we work together. By making pandemic prevention a top priority for humanity, we can protect not only our own species but the entire world from the devastating impact of these diseases.
So how do we combat the lurking, lethal germs in our ever-globalizing world? In Deadliest Enemy, Michael T. Osterholm advocates for aggressive collective action to subdue the dangers of emerging pandemics. Investments in innovative vaccine research, international cooperation, and a comprehensive One Health perspective are essential in tackling and preventing the spread of infectious diseases. By deploying groundbreaking medical measures, altering global agricultural practices, and acknowledging the interconnectedness of life on Earth, we can forge a resilient defense against the potential devastation of future pandemics. The journey has never been more pressing, our survival is at stake.